Hello, class. We're about to do section 4.7, which starts on page 447 through 448 and is 1 through 23i. Going to do a few problems, like for instance, number 1, number 5, number 11, number 13, number 17, and 21 and 23. Okay, now, starting with problem number 1 on page 447, we have the square root of a negative 25. Now, we could go here to our calculator. Let's take a look. See, we have the square root of negative 25, and it has it as undefined. Now, here's the thing with the Desmos calculator. You would have to basically okay, so with the square root of negative 25, as you notice here, we cannot put that in Desmos. It'll be listed as undefined. But this is what we would have to do here. This is what is called complex numbers. Now, with complex numbers, they go basically like this. We know that, let's disregard the negative for a second. The square root of 25 is just 5. Okay? But when we have the square root of a negative value, that produces the I. So the square root of negative 25 is equal to 5I, not just 5. Okay, now number 5, we have the square root of negative 48. Now we know 48, disregard the negative sign, we know that 48 is not a perfect square. So what we're going to do is to break this up into two radicals to pull out the highest perfect square of 48 is 16, and you add 3 left. But we would make this negative 16. We will put the negative with the highest perfect square. So the square root of a negative 16 would be 4i times the square root of 3. Okay, now we will go on to problem number 11. Problem 11, we have 5i plus 3 minus 7i. Now it says in exercises 9 through 13, perform the operations and express your answer in the form a plus bi, using your graphing calculator to verify the results. Now, here's the thing. With the Desmos calculator, we cannot verify these results, so we will be just doing this by hand. So 5i plus 3 minus 7i, we could rewrite that as 5i plus 3 minus 7i without the parentheses. 5i minus 7i is a negative 2i plus 3. Now, they do want us to write this in a plus bi form. So 3 would be our a, and the bi would be the minus 2i. So basically, we had to just turn it around. Okay, next, we have problem 13. Problem 13, we have 4 minus 3i times the parenthesis 1 plus 2i. So what we would do the FOIL method or distributive property. So we would do 4 times 1 plus 4 times 2i minus 3i times 1 minus 3i times 2i. So 4 times 1 is 4. 4 times 2i is 8i. Negative 3i times 1 is a negative 3i. And then negative 3i times a negative 2i. Negative times a negative is a positive. 3 times 2 is 6. And I times I is I squared. Okay, now we would have 4. 8i minus 3i is a positive 5i. Plus 6, I squared is negative 1. So we will have 4 plus 5i minus 6. 4 minus 6 is negative 2 plus 5i. And that is the final answer of problem number 13. Okay, now we will move on. Okay, class, I noticed I made a little error with problem 13 that I have to redo. So what I'm going to do with problem 13, we have problem 13. I'm going to rewrite it. I made one little error when I was multiplying. I took negative 3i and then multiplied it by a negative 2i, but it was supposed to be by a positive 2i. So let's go through this. So we will have 4 times 1 plus 4 times 2i minus 3i times 1 minus 3i times 2i. So this would be 4 plus 8i minus 3i. Negative 3i times 2i is a negative 6i squared. Okay, so we will have 4. 8i minus 3i is a positive 5i. Minus 6i squared is negative 1. So it would be 4 plus 5i plus 6. So 4 plus 6 is 10 plus 5i. And that would be your final answer. Okay, our next problem is 17. Problem 17, we had 2x squared plus 5x is equal to 7. So now it says in exercises 15 through 18, solve the quadratic equations in the complex number system using the quadratic formula. Verify your real solutions graphically. Verify that no real solutions mean no X intercepts. Okay, first of all, let's first make this equation equal to 0. So we know we're going to subtract 7 on both sides. So we had 2x squared plus 5x minus 7 equals 0. Now we're going to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we could list our a, b, and c off to the side. You can actually do that mentally. It'll be 2, 5, and negative 7. And we're going to substitute. So we add the opposite of 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 7 all over 2 times 2. So it'd be negative 5 plus or minus the square root of 25 plus 56 all over 4. Now, 25 plus 56 should be negative 5 plus or minus the square root. That'll be 81 all over 4. So x would be negative 5 plus or minus the square, well, it should be negative 5 plus or minus 9 all over 4. Because the square root of 81 is 9. So basically here we will have negative 5 plus 9 over 4. And then also negative 5 minus 9 over 4. So this will give us step 4 over 4, comma, negative 14 over 4. Now, when we put this in our calculator, this would end up giving us x will be 1, and then also x will be a negative 3.5. That is your final answer, because 4 over 4 is 1, negative 14 over 4 would give us the negative 3.5. So those would be your two solutions. Now, they did ask us to prove that if it's no real solutions means no X intercepts. Now, to prove that, if you look here at this X value here, X is equal to this equation, quadratic formula. So since X is equal to this is when Y is equal to 0. So whatever answer you get here, that is the X intercept. If there's an undefined answer here, that means that there is no x-intercept. That's what they wanted you to know and see. So if you graph it, a problem where you would not have x equaling to a value, that's when the graph would not hit the x-axis at all. Okay, so now that was 17. Our next problem is 21. 21, we have 4x squared minus 4x plus 1 equals 0. So now they ask us to determine the number and type of solutions of each equation by examining the discriminant. Now the discriminant is b squared minus 4ac. Now I believe, yes, the discriminant is b squared minus 4ac. Now, if you get a positive answer, that would mean that you have two real solutions. If you get a zero answer, that means that you have one real solution. If you get a negative answer, that means that you have two complex solutions, which means that you basically have two imaginary solutions. Okay, so we have b squared minus 4ac. So since this is set up in a standard quadratic form, a is 4, b is negative 4, and c is 1. So we're going to substitute. We have negative 4 squared minus 4 times 4 times 1. So this is 16 minus 16 is 0. So whenever our discriminant, so we're saying that b squared minus 4ac in this situation is equal to 0. So that means that it's only one real solution. Now, our last problem here, which would be problem 23. Problem 23, we have 12x squared is equal to 4x minus 3. We put this in standard form. We'll subtract 4x and add 3 to both sides. So we add 12x squared minus 4x plus 3 equals 0. So we're going to do our discriminant. So we know that A is 12, B is negative 4, and C is 3. So we add negative 4 parentheses squared minus 4 times 12 times 3. Negative 4 squared is 16. Negative 4 times 12 is negative 48. And then negative 48 times 3, let me see, that'll be negative. Negative 48 times 3 is 4, I think it's 134. Negative 48 times 3, oh, it'd be 144. Okay, so it'd be 144. 16 minus 144 is a negative 128. So now, we're saying our discriminant, our b squared minus 4ac is equal to a negative 128. So when it's negative, you add two complex solutions. So what that tells us is that we would basically have no x-intercept here. We would end up having values that we wouldn't even see basically on the graph, because the complex numbers, the graphs that we're making, basically deals with real numbers, not complex numbers. So this is basically it from this section. There was one other problem that I had thought about that I contemplated doing. So I think I want to do that problem, even though it's not listed here. But going back to page 447, problem number 8. Square root of negative 20 over 75. I did not do a fraction, which I would like to do a fraction. So now that we have this negative, what I would suggest that we do first here is see, first of all, is there any perfect square roots here? And it's not. So what we could do, let's simplify this. So this would be the square root. Both of these have 5 in common. So it'd be negative 4 over 15. Okay, so now, so we have the square root of negative 4 over 15. So we could break this up and make this the square root of negative 4 over the square root of 15. Now the square root of negative 4 we know is 2i divided by the square root of 15, and that is our final answer. Now it could be written like this, or sometimes you would see it written like this, 2 over the square root of 15, and then I in the center. I in the center is the same thing as I being in the numerator. So either one of these would be fine. And that is it from this lesson. Have a wonderful day.